Lesson 4.6, Operations with Complex Numbers. Complex numbers are a combination of real and imaginary numbers. We use the letter I to represent our imaginary values. The definition of I is if we square it, we get -1. So you can imagine if I took the square root of both sides, I would end up with I equals the principal square root of -1. So you might see it in either form. I cycles through 4 different values. So for instance, if I had I to the 0 power, anything to the 0 power we know is equal to 1. Then if I said I raised to the first power, we would know that I to the first power is just equal to I, just as 3 to the first power is equal to 3, 7 to the first power is equal to 7. So I to the first power is just equal to I. We continue on with I squared, and by definition, I squared is equal to -1. I cubed equals, and we'll break it into 2 parts, we'll call it I squared times I. And we know that I squared, we just said, was equal to -1. So -1 times I is equal to -I. And the last one we'll look at is I raised to the power of 4. So we'll have I cubed times I. And we just said that I cubed is equal to -I times I. And I can break that down into -1 times I times I. So we have our -1 times, and I times I is I squared, and I squared is equal to -1. -1 times -1 is equal to 1. So what I'd like you to notice is that we have 1, I, -1, -I, and then we're cycling back down to 1. So if we continued on and we said I to the 5th power, I to the 5th power would be equal to just plain old I. You might be asked to plot points on a complex plane, so I included 2 on this slide. And you'll notice that the imaginary values run vertically while the real numbers run horizontally. Complex numbers are written in the form of A plus BI, where A and B are real numbers and I is imaginary. So a plain old A is going to be the real part, and BI is the imaginary part. Off to the right, I have a reminder that I squared is equal to -1, and also that I is equal to the principal square root of -1. So for instance, if I had something like the square root of -3, and we wanted to simplify that, we know that we could break it up into the square root of -1 times the square root of 3, and we said that the square root of -1 is equal to I, and then we cannot simplify the square root of 3, so we simply bring it down. So I'm going to write 2 examples, and I'm going to ask you to try those. Okay, so try these 2 examples. Remember to pause the video and really work it out in your notebook. Okay, so the first one, we have the square root of -1 times square root of 81. We can simplify both, and we end up with 9i. When we work the second one, the square root of negative 18, I broke it up into 3 separate radicals. So the square root of 9 is 3. The square root of negative 1 is I, and we cannot do anything with the square root of 2, so I just bring that down. The standard form for complex numbers would be a plus b I. So again, that's the standard form. And we're going to try 3 where we're going to add. Okay, letter A. Given the square root of negative 12 plus the negative square root of 27. So you can see that I already factored. So if we take the square root of negative 1 is going to be I. We can find the square root of 4, so we end up with 2i square root 3 plus, we can find the square root of 9, so we have 3i square root of 3, and we can see our radicals are identical, so now we can just add 5i square root 3. Now we're going to take a look at letter B. So for letter B, we simply are going to combine like terms. So 4 plus 5, we end up with our 9. Negative 3i plus a positive 6i is plus 3i. And remember, we want to keep it in standard form, so that's the correct form. For letter C, we can distribute this negative, or you might say add the opposite. So 2 plus a negative 5 is negative 3. Negative 5i plus 2i is negative 3i. So for multiplication for this first example, we're going to distribute. So we end up with 14i minus 10i squared. And remember that I squared is equal to negative 1, so you could think of it as 14i minus 10 times negative 1, 14i plus 10. And we're not quite finished. We need to write it in standard form, so I'm just going to switch the order. So it's actually going to be 10 plus 14i. Now we'll try one using FOIL. Alright, so I started this one. I did the first step. Now we're going to combine our like terms. So 12 minus I minus 6 times negative 1, because I squared is equal to negative 1. 12 minus I plus 6. We combine 12 and 6. 18 minus I would be my final answer. The last thing we're going to do is work with division. As we did in a previous section with our radicals, we're going to multiply by a conjugate, but in this instance it's called the complex conjugate. So we will multiply the numerator and the denominator by 3 plus 4i. 3 plus 4i. And now we're going to FOIL the numerator and the denominator. Now that we completed our multiplication, we need to combine our like terms and simplify. So the 12i squared, we know that's the same as 12 times negative 1. So this essentially is equal to negative 12. So 12 and negative 12 cancel. So we end up with 25i in the numerator. The negative 12i and the positive 12i cancels. Negative 16 times negative 1, so that's actually equal to positive 16. So 9 and 16 is 25, and then we can cancel out the 25, so my final answer is just plain old I. Okay, the last one, I'm going to ask you to pause the video and try this one. Remember to multiply the numerator and denominator by the complex conjugate, and when you get to your answer, to write it in standard form. Alright, so we multiplied the numerator and the denominator by the conjugate, which means that because it was a 5 plus, we used 5 minus. Then we needed to simplify the denominator. The negative 4i squared, the I squared, remember, is equal to negative 1. So negative 4 times negative 1 actually gave me the positive 4. And so we're nearly done, but it says to write it in standard form, and standard form says a plus bi. So the last step is just to separate it out a little bit. So negative 15 over 29 plus 6 over 29i, and that would be the final answer.